Sorry, madam.
How
Sorry.
does thing end because you pressed it? Does it just end?
Oh no, I had stopped it, but now I needed to like,
Oh, okay.
yeah,
Okay.
make it go back again. But anyways, so we have a new question, right? But based on whatever we have just answered, which is like this similarity question, we cannot forget it. We have to somewhat try and make use of it in this question. And our sketch is important because this question here, you can see it's already talking about ratios and stuff. But anyways, they say it here, if LK is 12 units. So where is LK? LK is that line over there. Let's put the units in red, because if they give you lengths in a math question, like that's like gold, you know. This unit, this is 12 units. And then here, this is actually a ratio. The reason I'm saying this is a ratio is because you don't want to just keep it like this. They have told you that 3kn is equal to 4sm. Don't just leave it like that. So 3km is equal to 4s, no, kn, bro, n. Oops, n. 3kn is equal to 4sm. Now the idea is you want to put the numbers on their own, the variables on their own, or rather lines. So here what you can do is you can just divide both sides by like kn if you want. And then you'll have 3 here, 4sm, kn. And then the numbers you want them to be on their own. So here you can divide by 4, divide by 4. And then here the 4 is going to cancel that. And then here you have sm, kn. So now you know that this is just 3/4.
Wow.
Yeah. So this is important because another way you want to look at this is that the ratio sm to kn is just 3/4. Yeah. So multiple ways to view it, but this is also useful in a way because this allows you to not just work with two variables. You can just use one because you can always view kn as like 4/3sm.
Yes,
if you divide both sides by 3.
Yeah, that's what I did. So I didn't think you can get both.
Yeah, you can. You can if you want to isolate sm here, sm would be equal to 3/4 kn. You know, for some odd reason, if you maybe.
No, what I'm trying to say is that I got the value for SM is 3/4 kn, and the thing that you put up before. I didn't go further and get the 3/4.
Well, you didn't have to. If you did, it's just gonna be helpful for something. If you didn't, anything is really still helpful depending on how you use it. But then with what we have here, we'll see how this is gonna help us, right? Here they say determine the length of ks. Ks is this length over here. You see. Now the one thing you don't want to take for granted is that we have just proved that certain triangles are similar to each other. Now, again, like a good 99% of the time, let's just maybe say 95. 95% of the time, whatever you've worked out in the previous question is what's supposed to help you in a follow-up question. So before we even look at that question too aggressively, what we proved in the previous question was the fact that these two were similar, you see. So let's just start here for a bit before we can worry too much about what they're going to ask us. Let's just go back here. We can see here they're talking about ratios. So what I'm doing here is it's almost trying to give us the idea why past papers are important. The reason why past papers are important is they just almost give you the, what do past papers do? They give you a way to look at questions more logically than just from the top of your head and from your own thoughts. So you see here, even though I've gone through this question a few times, I'm not even trying to remember what we did in the previous questions. I'm literally just trying to remember how do you go about answering questions that fall after each other. As long as you've proven similarity here, and here now they're talking about, you know, ratios and everything, and they're asking for like KS, before you even worry about that, just try and find out what ratios you can write out from this. As long as these are similar, right? We know that we can write out something like LK over KS. Let's write here, LK over KS is equal to KN over SM, KN over SM, which is also equal to ln over km, which is equal to ln over km. Now, the reason for writing all this will just be proportionality of similar triangles, prop of sim. Let me just write it out in full so that it's like, you know, visible. Proportionality of similar triangles. Triangles. Obviously, in short, you can always just write proportionality theorem, prop theorem, like legit. Just write it like that. So you can see here we've written out three things that are definitely correct. Now, these three things can definitely help us. The fortunate thing is, you see what we wrote up here, we have Sm over Kn. It doesn't matter if you flip this around, because you can see we have the Kn on top, the Sm at the bottom. This, if you want to write it like this, fine. If you want to write it flipped around, you can also do it. You can have the Kn on top, the Sm at the bottom. You can just flip these numbers, 4 over 3. It's all the same. Now, they're asking us to get the length of Ks. Like we can already see where our length of Ks is going to come from. We can already see it, see that what we have here is going to help us. Mainly because firstly, it becomes so blunt to say, okay, wait a minute, that's why they gave us that information. Because them having to have given us this, it's how we now have this, of which that takes into account this whole thing here. Furthermore, we need Ks, of which that's where this is going to come in. So of these three, it looks as though only this is helpful to us. Now, the fortunate thing is, even though it's like a 4-mark question, it's just so plain in our sight that, okay, wait a minute, we really are not doing a lot. We're just making use of what we have. And you can see what's important is to know why they've given you certain information, not to know too many things really. Because when you think of it like that, it just becomes almost, becomes too good to be true. Because here there's the LK they gave us, there's the Kn over there's the Kn over Sm that we already have, and then there's this missing question that they're asking, you see. So if you put everything in your equation, the ratio here, you already have it, or whatever this is in its simplest form, because it doesn't matter how Kn and Sm are specific lengths. We don't know their specific lengths, but then this is telling us that those lengths in their simplest form, it's just going to be 4 over 3. The top one here could be an 8, the bottom one could be a 6, it doesn't matter. This is just telling us that in their simplest form, it's just 4 over 3. And then on the other side, we also know that, okay, if the ratio is 4 over 3, right? Here it's like 12 over Ks, of which we can just work out Ks algebraically. You see?
Yeah.
Yeah. And then because this is like a fraction and a fraction, the one way we can work it out is to just cross multiply. Ks times the 4, 3 times the 12. 3 times the 12 there gives us a 36. Ks times the 4, 4 Ks. And then here we can divide both sides by a 4. That's what it gives us here. What is 36? I think a 9. Oh, yes. Ooh, nice. Nice. Yes, it's a 4. Yeah, no. Yeah, 9. So anyways, let's see here. What's that thing? Yeah, so Kn is 9. I mean Ks, sorry. That's going to give us these 4 marks here. And you can see we didn't necessarily struggle. What we had was, okay, we have worked out, everything is working together. Like it's almost like yeah. I feel like repeating it over and over again, it's going to make me sound like a mad person. So I'll just hold on for a bit. I'll just hold on. But you can see how everything is just working together, right? And we have 4 marks here. So we can move on to the next one. So let me just do this.